We want to insert slashes in between the letters in a Matic SML so that we get 4 groups with each group including at least one letter. Well, one way that we could do that is we could put a slash between the M and the A, and one in between the T and the Y, and one in between the M and the L. Those 3 slashes separated into 4 groups, at least one letter each. So what we're really doing is we're looking at how we can put 3 slashes in between these letters. And there are 8 places to put slashes. We could put them between the A and the M and the A and the T and the Y and the C and the S and the M and the M and the L. So there are really 8 different places where we could put a slash, and we want to choose 3 of those places. And each different set of 3 that we pick is going to be a different way to separate this string of letters into 4 groups. Now there's actually a really nice formula for this. There's a formula for when we have n objects and we want to choose k of them. We write this NCK, C for choose or combinations, because we're looking for the number of combinations that we can do this in. And the formula tells us to take n factorial over k factorial times n minus k factorial. So in this case, we're taking 8 choose 3. That's going to end up being 8 factorial over 3 factorial times 8 minus 3 is 5 factorial. Now, a number factorial is the product of all of the whole numbers between that number all the way down to 1. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. And 5 factorial is 5 times 4 times 3 times 2 times 1. And we need to figure out what this equals. Now we can cancel a lot in the top and bottom. We can immediately cancel out the 5s, the 4s, the 3s, the 2s, and the 1s, because those are common factors. But we also notice that the 3 times 2 in the bottom is equal to the 6 in the top. So if we cancel those out, we've canceled out a 6 in the top and a 6 in the bottom. That leaves us with 8 times 7, which is 56, which is answer choice B. But let's talk about where that formula comes from. In this problem, we have 8 possible places for the slashes, and we want to choose 3 of them. Let's try to do that without using the formula, and then see how this formula makes sense. We have 8 possibilities, and we want to put the first slash in. Well, there are 8 places to choose from. We have 8 different possibilities for that first slash. We could put it at 1, 2, 3, 4, 5, 6, 7, or 8. But for each of those possibilities, if we're looking at the second slash that we're drawing in, there are only 7 choices left, because we've already put a slash in one of those 8 places, and we can't put 2 slashes together, because then we'd have a group that doesn't have any letters in it. So there are 7 possibilities for the second slash, and then when we need to put the third slash in, 2 of those 8 are already taken, because we've already put down 2 slashes. That means that there are 6 possibilities left. So we have 8 times 7 times 6. But that's not the whole thing. We've actually overcounted. Look at the example that we have above. The example that we have above comes from if we put a slash in the second slot, and then a 4th slot, and then the 8th slot. But what if we had instead started with the second slot, and then the 8th slot, and then the 4th slot? Or if we had started with the 4th slot, and then the 2nd, and then the 8th, etc. There are actually 6 different possibilities that give us the same slashes as the end result. 248, 284, 428, 482, 824, and 842. And the reason there are 6 possibilities is because of those numbers, we can pick either 2, 4, or 8 for the first one. So there are 3 choices for which one went first. There are then 2 choices left for which one went second. And then there's 1 choice left for which one went last. So we can see that there are actually 8 times 7 times 6 over 3 times 2 times 1 possibilities in total. Now this is fine for a final answer if we go through and do the math, but we can actually change this to put it in a better form. We can multiply the top and bottom times 5 times 4 times 3 times 2 times 1, which might seem excessive, but if we do that, we notice that the numerator is the product of all of the whole numbers from 8 down to 1. That's 8 factorial. And then the denominator is 3 factorial times 5 factorial. But 5 is just 8 minus 3, so this is 8 factorial over 3 factorial times 8 minus 3 factorial, which is what we had when we wrote 8 choose 3 earlier. It works the same whether you're using 8 choose 3 or 9 choose 5 or 12 times 6. You end up getting the same thing. And so the formula n choose k, which is given by n factorial over k factorial times n minus k factorial, works whenever we have n objects and we're trying to choose k of them, and the order that we choose them doesn't matter. This is an important formula that's used often in math competitions, and I'd highly recommend that you not just memorize it, but play around with it and get to know it.